Hello everyone, I am going to explain the UNETR++ paper. So the main motivation behind this paper, CNN based model have been used for 3D image segmentation based on their encoder and the decoder principle, but they struggle to achieve high accuracy due to the limited receptive field. By limited receptive field we mean that the small filter size that they use are local, can capture only local context and not the global context. Although by increasing the number of layers, we can capture the global context, but that can lead to loss of fine details. So in this image, I have shown this yellow box as the filter, and that this image as the 3D image. Now, transformer-based models can capture global context, and but that but the self-attention mechanism in transformer increases the computational capacity. And some recent hybrid models have been used that uses the power of both CNN and transformer models, but that models are highly complex, and they increases the number of parameters and the floating point operations in the models, which leads to unsatisfactory robustness. And this paper tries to solve this problem by increasing this segmentation accuracy, and also to make the models efficient by decreasing the number of model parameters, flops, GPU consumption. By introducing a novel efficient pair attention block mechanism in the unit based architecture. The the unit R++ model is based on the unit architecture. It consists of encoder and a decoder layer with skip connections. So Af- So the first encoder stage consists of patch embedding. In patch embedding, we convert a single image into we divide this image into small patches. For simplicity, I have shown only three patches. So and then each patch is converted into flattened into 1D vector. After this 1D vector is formed, this 1D vector is passed through a linear layer with positional embedding, so as to decrease the dimension of the vector. And finally, it is passed through the EPA block. The vector that is passed through the EPA block is of dimension n cross c. Now the EPA block. The EPA block consists of two modules: the spatial attention module and the channel attention module. Both this module works parallelly. So for a single patch, we compute the query, key, and the value. What does this means? Query means it is a pixel or a vector that looks for another pixel to pay attention to, and the key means it is a pixel that is looked by other pixels, and value is the actual pixel value or the vector. So in the paper it is given q shared and k shared. That means both the module the uses the same query and a key, so as to decrease the number of parameters in the flops. And in the spatial attention module, we compute the v spatial and value spatial, and similarly for the channel attention map, we compute the channel value. We compute this key, query, and value using their trainable weights through a linear function, that is y is equal to wx plus b, where b is the bias, w is a learnable weight. So the spatial attention module, so the main function of this module is to reduce the complexity, and the complexity is reduced by decreasing the dimension of the query and the v layer. So the k shared and v spatial are projected from dimension n cross c to a low dimension of p cross c, where p is much smaller than n. After we perform softmax function to convert it to probabilities, and then we perform multiplication with the projected spatial value spatial layer, and finally we get the same dimension as the input value as it is shown here. So the main function of this module is the to find the long range dependencies between the spatial resolution. Like so it mainly asks what is my relationship with other important voxels, or other important pixels in the entire image. And then the channel concern. The main motive of this module is to find the interdependencies between between different channel feature maps. So in this layer, no projection is performed. The same query and a key is used, uh, and then softmax function is used, and finally multiplication with the value channel at layer. And then we get encrosty, which is the same in dimension as the input image. So we get secrecy, which indicates the interdependencies between different types of features, like which features is more important to and which features we can pay more attention to. So after the image, so as shown here, the after patch embedding, we pass the image to the EPA block, and after the that we pass the feature maps to the downsampling block. In downsampling, we reduce the resolution of the image by a factor of 2, as given in the paper, and again it is passed to the EPA blocks. This process continues for 4 different layers. So after the bottom layer, the image is upsampled. So during upsampling, we increase the resolution of the image, and simultaneously we also add the feature map from the previous encoder block, so that there is no loss of information, and proper feature maps are added to the efficient pair block. This process also continues for 4 different steps, and finally, after the last EP block, we and the upsample to recover the spatial information and to enhance the feature representation. And finally, we have the most enhanced feature map. So, and after we perform 2 convolution, the first convolution is the 3 cross 3 convolution block, and after that 1 plus 1 plus 1 block to predict our or to find our final prediction. So in this way, it achieves high accuracy, and also it reduces the parameters and flops, making the model highly efficient. And I have used this model for my histopathology dataset. Although the results are not so impressive, I am trying to make the results looks good. These are the result analysis, and thank you.